What is the resistance of a copper wire, diameter of 1.5 millimeters and length of 25 meters? So for this, we're going to use the equation resistance equals the coefficient of resistivity times length all over surface area or area. So this equation is something we actually haven't been given in class, so I wouldn't expect to see it on the test or anything like that. However, I'm still going to work it out because it's on the FRQ sheet. So I looked it up, and the coefficient of resistivity, and again this is a coefficient like the coefficient of friction or the coefficient of restitution, and the coefficient for copper would be 1.7 times 10 to the negative 8th, and it's in watt meters. Now you can guess that this is a very small number, and you can guess it's small for the coefficient of resistivity, and this basically says that copper is not very resistant, which means it's good for allowing electricity to travel through it, which means it's a good conductor. Okay, so there's a fun fact. So the area. For the area, we see diameter, so we know we're dealing with the area of a circle. So the area, would be pi r squared. Now the diameter is 1.5 millimeters. First, we have to convert this to meters, right? Because we're dealing with standard units, SI units rather. So yeah, this is the diameter in your SI units. Now, the radius is just that times a half, right? Because that's how radii work. So that's what I did. I said it's 0.0015 all over 2, and then I said it's that all squared. So it's the radius squared times pi r squared. For that, we get, let's see. Well, let me just find the number right now. Times. We get a very small number, 0.00, believe it or not. Okay. 0.001767. Very small number. Yep. Okay. So, and we know the length already. That's in your standard units. So we essentially do 1.7 times 10 to the negative 8th times 25 all over 0.00001767. And for your answer, you get 0.24 or 0.24 ohms. And for number 5, okay, so essentially this is number 2. These are, I'd say, these are number 1. This is number 3. That's number 4. So for number 5, we'd say, yes, it makes sense, as copper wire is a good conductor, and so its resistance is low. And yeah, that's number 5. And again, I wouldn't expect to see it on the test, but you know, I solved it, so yeah.